This is going to be a video on how to do one of the homework problem. I'm going to try in particular problem number 6 in the book. What is the Fourier series of this piecewise defined function? Defined in this way. Well, the Fourier series is going to be a0 over 2 plus sum an cosine nx plus bn sine nx. Notice that nx is actually n pi over px. But since n is equals to pi, it reduces to just nx. The formula for an, bn are given by such. That's the formula. A0 is going to be this formula. An is going to be this formula. Bn is going to be this formula. If you are doubtful about what I wrote, they're actually the simplified form of the formula in page 426. So let's start with how we can calculate A0. Okay, as you can see, A0 is this integral here, and I've broken up the integral from minus pi to 0 and then from 0 to pi. But we know that from minus pi to 0, the function is pi squared. From 0 to pi, the function is pi squared minus x squared. So if we do the integral, we'll get 1 over pi here, and this is just pi squared multiplied by 0 minus negative pi. This will be a pi squared x minus 1/3 x cubed from 0 to pi. And that would be 1 over pi cubed plus this will be pi cubed minus 1/3 pi cubed. So, and minus a whole bunch of 0. And the answer is going to be pi over 3 plus 2/3 pi over 3. That's 5/3 pi, 5/3 pi cubed. Pi cubed dividing by pi is pi squared. So 5/3 pi squared. We found A0. How do you find AN? Okay, according to the formula, AN should be given by this integral. This integral over here. So, and if you can see clearly, it is the same kind of integral from minus pi to pi, but I've broken up into minus pi to 0, 0 to pi. Unlike the example in the book, this one actually requires us to put, this is not 0, so this is actually pi squared, and that's pi squared minus x squared. Okay, so integrating this, we will get, integrating cosine of nx, you get sine of nx over n. And we have to substitute x equals to 0, substituting x equals to minus pi. But we know that's going to be 0, so this whole thing is going to be just 0. But for the other one, we need some kind of tabular method. And I have the tabular method done here. So if you can see, here is the tabular method for that problem. So if I put it up here, let's see if you can see it. The answer will be, it's going to be 3 different terms. It's going to be this times this times this. This times this times this. And this times this times this. That is going to be, let me write a little smaller here. Pi squared minus x squared sine nx over n. And then this is going to be a negative 2x cosine nx over n squared. And then you have to add one more term, which is plus 2. So I'm going to write down here. Plus 2 sine nx over n cubed. And both of them will go from 0 to pi. If we substitute the values inside, this will be 0. Okay, we are going to get, substituting pi inside, we are going to get 0 because pi squared minus pi squared is in fact 0. So this is going to be 0. And this will be 2 pi cosine m pi. And that will be 0 because sine of m pi is 0. And if you substitute 0 inside, you're going to get 0 because sine of 0 is 0. And you're going to get 0 here because 2 times 0 times cosine 0 is 0. And this is going to be 0. So this is what we get for an. So an, if we simplify, this pi cancel with this pi, will just be negative 2, negative 1 to the n over n squared. That is my an. Or you can actually simplify that to 2 over n squared, negative 1 to the n plus 1. What would Bn look like? Bn will be this formula over here. And for the same reason, we need to integrate pi squared sine nx and pi squared minus x squared sine nx. Integrating pi squared sine nx is easy. It's just going to be negative pi squared cosine nx over n, x running from minus pi to 0. And integrating this requires a tabular method, which I have here. I prepared here. And it will be a similar one, but different from the one I had just now, because it's going to be sine nx. So having this table, using tabular method, I know what this will be. This will be, there'll be 3 terms, pi squared minus x squared, negative cosine nx over n, negative 2x sine nx over n squared, and the last term is also negative 2 cosine nx over n cubed. All these will have x value running from 0 to pi. So you do something similar to what I had just now, you will get an answer for Bn. And once you get all the answers, you're supposed to put them back in this formula over here. So put in your A naught, which I know is 5 pi over 3. So 5, sorry, not 5 pi over 3, but I got 5 pi squared over 3. So that's going to be 5 pi squared over 6 plus an is going to be 2 over n squared minus 1 to the n plus 1. So 2 over n squared minus 1 to the n plus 1 cosine nx. I don't know what Bn is. You fill that in. It's going to be some big ugly thing, sine nx. And then that's your your Fourier series for f of x. And you have to write the first 3 or 4 non-zero term for this, plus a whole bunch of this which involves 3 or 4 non. So your final answer should kind of look like this. Something cosine x plus something cosine 2x plus a whole bunch of others, and then something sine x plus something sine 2x plus a whole bunch of others, and that will be what your answer will look like. And make sure this something are non-zero.